Hey, space explorers. Imagine a cosmic wanderer from another star system zooming through our neighborhood right now. That's 3I-ATLAS, the interstellar comet that's got astronomers buzzing in 2025. Discovered just a few months ago, it's revealing wild new secrets, from its massive size to possible solar storms hitting it. In this video, we'll break down the latest info and why some think it might be. Well, a bit weird. If you're into space mysteries, hit that like button and subscribe for more cosmic updates. Let's dive in. What is 3I-ATLAS? First off, what makes 3I Atlas special? It is the third confirmed interstellar object we've spotted after Oumuamua in 2017 and Borisov in 2019. Unlike comets born at our solar system, this one's a visitor from deep space, ejected from another star long ago. It was first seen on July 1st, 2025, by the Atlas telescope in Chile, looking like a faint blur moving super fast, about 60 kilometers per second. Show visual animation of its hyperbolic path curving around the sun and slingshotting back out. Discovery and early observations, astronomers quickly realized its orbit was hyperbolic, meaning it's not bound to our sun. It came from the direction of Sagittarius and will head out toward Pegasus after its visit. Early Hubble images from July showed a teardrop-shaped dust cloud around it, confirming it's an active comet with ice turning to gas as it warms up. By August, the James Webb Telescope jumped in, spotting water ice, CO2, and even nickel vapors, stuff that hints at how planets form in distant systems. Physical properties and new size estimates now. The juicy new info from September 2025. This thing is bigger than we thought. Hubble's latest data pegs the nucleus at up to 5.6 kilometers wide, that as like a small mountain, and weighing over 33 billion tons. That's anomalously massive for a comet this active. Diameter 0.44 to 5.6 km, mass 33 billion tons, speed at perihelion 68 kilometers as composition. High TO H2O NICO Gemini South Telescope caught its tail growing longer, stretching out as it gets closer to the sun. And get this, on September 25th, a coronal mass ejection from the sun smacked into it, potentially supercharging its coma and making it brighter for observers. Recent updates in science missions as of late September, ESA's Mars and Jupiter missions are tracking it too. Mars rovers like Perseverance might snap pics during its close flyby on October 3rd, just 0.02 astronomical units away. JUICE, heading to Jupiter, will try observations in November. No probe missions are planned, it's too fast for us to catch, but telescopes worldwide are on it until it dips behind the sun later this month, reappearing in December. Controversies and speculations. Here's where it gets controversial. Astronomer Avi Loeb suggests anomalies like its huge mass, no extra push from gas jets, and orbit hugging the ecliptic plane, our planet's path, make it seem ... artificial. Like maybe alien tech? He points to the nickel without iron, which could mimic manufactured alloys, and its perfect approach to planets like Venus and Mars. But hold up, NASA and others say, nah, it's just a funky natural comet. Observations show classic gas emissions, and the mass could just mean it's dense ice rock. No evidence of tech, but it's fun to speculate. Future and wrap up what's next. 3-1 ATLAS hits closest to the sun on October 30th, then fades away forever. It is a reminder of how vast the universe is and how much we still don't know. Do you think it's alien? The interstellar comet 3I-ATLAS, discovered on July 1st, 2025, by the Atlas Survey in Chile, represents a rare opportunity to study material from beyond our solar system. Initial observations classified it as a comet due to its coma and potential tail, visible as early as July 2nd, 2025. Pre-discovery images trace back to May 7th, 2025, from facilities like the Zwicky Transient facility. By mid-July, Hubble captured a teardrop-shaped dust envelope, estimating the nucleus at 0.32 to 5.6 kilometers in diameter, likely under 1 kilometer when accounting for the coma. The coma spans up to 26,400 kilometers, with a dust tail and sunward plume, and a rotation period of about 16 hours suggests an irregular shape. Composition studies, primarily from the James Webb Space Telescope, JWST, on August 6, 2025, and SBHRX August 7th to 15th, reveal a high CO2 to water ratio, 8 to 1, alongside water vapor, carbon monoxide, carbonyl sulfide, and cyanide. Notably, atomic nickel vapor was detected without iron, an unusual trait potentially linked to formation beyond the CO2 frost line and its parent system. The Very Large Telescope confirmed cyanide emissions increasing with solar proximity, while depletion in carbon chains hints at unique chemical evolution. Recent September 2025 updates emphasize its anomalous mass, over 33 billion tons, inferred from minimal non-gravitational acceleration despite a mass loss rate of 150 kilograms per second at 440 meters per second outflow. This suggests a density implying a larger than expected nucleus, challenging models of interstellar object abundance. Gemini South images from August 27th showed a faint antisolar tail, growing as activity ramps up. Predicted CME impact on September 25th could enhance visibility, as modeled by NASA, potentially boosting coma brightness. Orbital highlights include close approaches. Mars, 0.018 astronomical units on October 3rd. Venus, 0.65 astronomical units on November 3rd. And Jupiter, 0.36 astronomical units. Its retrograde orbit, inclined just 5 to the ecliptic, offers a 0.2% probability coincidence, fueling speculation. Earth remains safe at a minimum 1.8 astronomical units on December 19th. Exploration is limited. No feasible Earth-launched probe due to required delta-V exceeding 20 kilometers per second, though a Mars-based launch was theoretically viable in July-September 2025 for an October flyby. Ongoing observations involve Mars assets, Perseverance, Curiosity, Mars Reconnaissance Orbiter during the October 3rd encounter, and ESAS JUICE mission in November, with data expected by February 2026. Ground networks like Interstellar enable citizen contributions. Controversies arise from Avi Loeb's hypotheses, positing technological origins based on size rarity, 3 to 5 orders larger than prior interlopers. Ecliptic alignment 1 in 500 chance, nickel-iron imbalance resembling alloys, and absent acceleration suggesting artificial propulsion. A July 2025 preprint explored dark forest implications, suggesting hostile intent via planetary proximity. Critics, including Chris Lintott and Daryl Seligman, counter with evidence of classical cometary activity, gas spectra, tail formation, dismissing artificiality as unsubstantiated. NASA debunks such claims, affirming natural status. Future visibility, observable until late September 2025, then in solar conjunction until early December. Post-perihelion, it may brighten to magnitude 12, accessible to amateur telescopes. Trajectory tracking via NASA's EYES app provides real-time visualization,